Welcome everybody, welcome to Council-Led Housing Forum. I can just see there's a couple of people still coming into the room, so hopefully you'll be in the room with us shortly. So Council-Led Housing Forum is hosted by Future of London. Future of London, if you don't know us, we're all about networks, knowledge and leadership. This forum was set up and was sponsored, I should say is sponsored by the GLA, by BPTW, Potter Raper and Red Loft. So my name is Visca Sri Chandrasekhara and I'm the Council-Led Housing Forum Manager. Now then, today's topic is net zero. And before we get into that, I'm just going to do a few little bits of housekeeping. So our first presentation on achieving net zero carbon in practice. We have Joel Callow from Coda Consulting, Neil Campbell and Dido Graham, who are both from BPTW Architects. And they'll probably say a little bit about themselves when they introduce. But Neil is a partner. Dido is also a passive house specialist, and Joel is a sustainability specialist and also does work on daylight. Okay, that's a really brief and probably not doing justification, but I want to hand over now, firstly to Joel.
Good morning, everybody. A pleasure to be with you. I hope you're hearing the audio nice and clearly. So welcome from me. My name is Joel. I'm from Coda. My role does also include passive house design, actually, like Dido and some of the guys at BPTW. So you're going to get lots of thoughts about eco buildings today, but we're going to start. My part of the presentation is to set the scene, actually. And then Dido and Neil will do some more detailed thinking about what that means for sustainable buildings for all of us in our day-to-day professional lives. So scene setting for net zero carbon has to start with climate change, unfortunately, the climate emergency. But I thought you might be amused to see this cartoon from early 2020 when we were being told to sing happy birthday to ourselves whilst washing hands. I know that seems like a very distant memory now. It still makes me chuckle. That in fact, COVID has been such an incredible impact to all of us. Just almost nobody has been unimpacted by this pandemic. And yet it actually sits well below these other challenges we're facing as humanity. And of course, today our topic really is the climate emergency. So next slide, please. And we're going to just rattle through climate change very quickly. And the reason for that is that there's some confusions around the level of urgency and responses to it. I think it's just better if we state at the start what we mean by the climate emergency and what response we're expecting. So next slide, please. So here's the latest data. This is straight out of the IPCC report, and I've actually annotated it, so it didn't come with the emojis. You'll be surprised to hear. The scientists are fantastic at global climate science, not so good at naming things and making them clear for everybody else. I've taken the liberty of naming these scenarios that the scientists have presented to us. These scenarios are our future as humanity. We have to pick one and then we have to deliver it. And I would suggest that the okay to bad scenario is probably our best bet to hit this globally agreed 1.5 degree Celsius target. So that's the biggie, 1.5 degrees. I think nearly all of us are aware of that reality now. That's what we're trying to do. And that's therefore what the rest of the presentation really is discussing. How do we get ourselves, our country and our entire planet down to a 1.5 degree climate change outcome in the future? So next slide, please. Here's what has to happen. So this is the CO2 emissions of the whole of humanity, all added up together, which must have been a bit of a job. These, of course, are projected out from today through to 2100. And these are the scenarios the scientists use to predict what will happen to climate change. So they're not allocating likelihood to these scenarios. They're simply saying, this is what could happen if we do this or that or the other. And there's been a lot of debate about that in the papers. I won't say much more about that. What I will say, though, is they're not very good at naming things. So the one we need is the little light blue line at the bottom, which is handily titled SSP 1 to 1.9. I think that's not especially catchy, so I call that one the happy blue line. There's actually a slightly less happy blue line just above it. But the happy blue line, or the light blue line, is the one that delivers confidently, or reasonably confidently as far as the scientists are concerned, a 1.5 degree-ish outcome. And then the other scenarios variously produce much, much warmer outcomes with much worse global impacts really across humanity. So we need the light blue line, a happy blue line, and we need to think about how on earth we deliver that. So next slide, please. Just one more brief mention about climate change, and then we'll roll into the next part of this. That is to say that because climate change is not a result of today's emissions, it's a result of all our emissions so far to today, and therefore what happens in the future too. We are heading up this line steadily, moment by moment, day by day, month by month, as we collectively emit more carbon. What we have to do, and normally flatlining is bad news. Certainly for human beings, flatlining is very, very bad news. But for carbon emissions, cumulative carbon emissions, flatlining is exactly what we need to do. So this line's got a gradient at the moment, it's heading up. What we need to do is stop emitting carbon so that all the cumulative emissions that have happened so far are all that then happens. So we reach global net zero, this graph becomes horizontal. And that's what the scientists need us to do. That has to happen before we hit the end of the blue band on the graph here. So you can see we're working our way up through the blue band at the moment, and we need to stop emitting carbon before we get to the end of it, which is 3,000 gigatons CO2. So that's what we're trying to do. Cumulative carbon, every kilogram counts. So we need to cut now and cut hard. That's the message. Okay, next slide, please. So next, we're going to zoom in a little, or kind of, onto this term net zero carbon, which is the title of today's session, and it's a term we're all very familiar with, although it was only coined relatively recently, and we talked about carbon neutral historically, so you may be familiar with that term. But today we're considering net zero carbon. What does it mean for us as buildings professionals, and what does it mean for everybody else as well? So next slide, please. At a very basic level, net zero carbon isn't too difficult to define. It means we stop consuming any sort of fossil fuel, but specifically burning them, and by that we mean coal, oil and gas principally, though methane is also an issue. And instead of using those, which have those are a linear, non-cyclical consumption pattern, we move to a cyclical consumption pattern whereby the things we use regenerate automatically. And that includes the materials we use, but crucially, the energy. So wind turbines, solar panels, biogas, and so on. Anything that can renew cyclically and continue to operate in perpetuity in the future is renewable. And that's what we need to swap over to globally. So far, so easy. Net zero doesn't sound too difficult. Next slide, please. But there are, of course, some challenges, and this is where we begin to focus more on our own industry, the industry of construction and building operation. So you'll see that constructing buildings emits about 6% of the global human total, carbon emissions total, but operating buildings, particularly residential buildings, contributes about another 30% to the global total. So buildings are, as you're probably all aware, a very, very substantial part of the problem, both operational, which we're focusing on today, and embodied carbon, which is the construction part of that pie chart. The next slide, please. Okay, so now let's think about net zero operational carbon for an individual building. And this is where it gets a bit fiddlier, or let's say a building or a site, a collection of buildings. So we've zoomed right in from the global to the national to the local. And we're saying at this point, net zero carbon for us, and this is the sort of go-to definition I think that the industry is now using, give or take, is that over a given average year, so this is not a sort of, it's a notional thing, not an actual thing at some level, over a notional year, the energy consumed by a building, demanded by it as a result of the things happening inside it, is balanced by the amount of renewable energy that that same building or site generates. And if those two balance over the course of a year, or indeed if the renewable energy is greater than the energy consumed or demanded, then you have a net zero or better than net zero carbon building. That's not 100% accurate, but it's the nearest we can get to a simple definition, I would say. This is ignoring things like offsets, and also it doesn't consider the idea that green tariffs via the national grid or gas grid have any real benefit to a building. So we're saying local balance between energy generated and energy consumed is net zero. Next slide, please. Okay, don't be alarmed. I'm not going to talk through this one in enormous detail. These are future energy scenarios that are publicly available from the national grid. And I've chosen one here that shows a future in 2050 that's net zero carbon, which is of course what we're trying to achieve for the whole of the UK. The whole of the UK's energy needs, including buildings, and you'll see different categories down the right-hand side there. And all I'm going to point out here really is to say that it seems to me, and this is a personal opinion, extremely unlikely that the hydrogen economy is going to fuel the heating needs of buildings in the future to any great extent. There might be some limited amount, you can see it on this graph here, this graphic, but my personal opinion is we're going to need to use things like heat pumps to electrify our buildings, and we'll talk more about that later. So just to say, hydrogen probably won't save the day. It seems to be very unlikely it will. Politicians disagree. Of course, they're very welcome to. The gas industry, interestingly, also disagrees with me on this one, but most sustainability professionals agree that hydrogen is not going to roar in and avoid the need for energy efficiency and heat pumps. Okay, next slide, please. So perhaps heat pumps are going to save the day. If hydrogen isn't going to, perhaps heat pumps will. Well, they may do, and they're certainly a fantastic technology. They will be zero carbon in the near future, as you can see from this graph. They are relatively easy to retrofit to existing buildings, which is crucial because we have millions, tens of millions of existing buildings. But they do have their challenges, which I'll come on to. Next slide, please. And this is probably our biggest challenge. And this is the key point to my part of the presentation before I hand over to Neil and Dider. So the key issue is that we use an awful lot of natural gas in the UK at the moment, and it's mainly used for generating power and for meeting the needs, the space heating demands of our buildings in the winter. So the challenge arises that the gas grid is just enormous compared to the electricity grid. It's not something most of us think about much of the time, thankfully. But in fact, when it comes to zero carbon buildings, this is absolutely crucial. Imagine we all switched off our gas boilers right now and went through this coming winter without any access to gas. And miraculously, we had 20 million heat pumps available that we'd all installed at the same moment, ready to use for the winter. What would happen is we would demand from our national grid enormously more electricity than is actually available at peak demand across the winter. Let's look at the next slide, and it explains that a bit more clearly. So 350 gigawatts is our gas demand. That's the problem today. Got to switch it off, got to stop using gas. Gas is a fossil fuel. There is a biogas question, but that really hasn't got the scale to answer our 350 gigawatt problem. So even with super duper heat pumps, and I'm a big fan of super duper high efficiency, high COP heat pumps, you still end up with a peak demand of circa 120 gigawatts. And that's in addition to what we normally use electricity for anyway, including now charging electric cars. So we've got a problem. We've got a problem that what we need is a giant gush of electricity from a high pressure tap, if you like. What we've actually got is a trickle of electricity from not at all high pressure tap. And we've only got 50 gigawatts available instead of the circa 200 we probably need all in for all of this going on at the same time. So we've got a capacity problem. We can't simply swap to heat pumps. In a way similar to the idea we can't simply swap to hydrogen because there isn't enough of it. We can't generate it easily enough. Next slide, please. So a summary of my points so far would simply be that we can get to net zero on electricity. The problem is there's not enough of it to heat our buildings, even in the best case scenarios, with as much hydrogen as we can muster, the very best heat pumps at the highest efficiency. We simply need too much heat for that system to meet all those energy needs. And therefore, we need to make our buildings less wasteful, both our new buildings and of course, all the ones that already exist. Next slide, please. And there's another problem as well, another challenge, and that is that electricity is not cheap. Now, it may go down in price, and there are some projections saying that it will as renewable energy comes online in greater quantities. But on the whole, heat pumps cost more to operate than gas boilers do. That's partly because of the way gas isn't taxed and electricity is. So there's some ways we can tweak this, and we can hope that government policy follows those sorts of protocols. But overall, electricity is a much more processed fuel than gas. We just dig gas up out of the ground, which is pretty cheap. But we actually have to create electricity or convert energy into electricity from other forms, and that's generally more costly. So we can't resolve fuel poverty with heat pumps. We have to address the amount of heat that our buildings need as well. Next slide, please. Now, I'm just going to briefly conclude with embodied carbon, because it would be remiss of me to focus the entire part of my presentation on operational carbon. Then I'll hand over to Neil and Dider for some buildings-focused excellence. So embodied carbon is the content of the building materials we use as they're brought to site and used to construct buildings. Concrete is the obvious example. In its worst form, it has a lot of carbon in it because of its cement content, although there are ways to make that better. And timber is an example of a fantastic material that has actually captured carbon, so has a carbon negative footprint in some ways. The industry hasn't really dealt with embodied carbon up until now. I want to say very clearly that there are now quite good but complex answers to how we measure and minimize embodied carbon. And if we wish to build buildings with a very low embodied carbon footprint, we can do so, although probably zero would be a bit of a push at the moment for most projects. But it's a very new industry. So unlike operational carbon, which I've talked about for the last few minutes, which has decades of knowledge and case studies and benchmarks and regulation behind it, embodied carbon has none of those things. And so we're kind of stepping out into a bit of a wild west of slightly unknown performance and a lack of case studies. There are a few, and I wouldn't want to do it down, but I want to warn you that this vital part of our total fight for climate change, against climate change, is much less clear than the operational carbon. So my final slide, please. So embodied carbon, unfortunately, whilst being a difficult one to tackle, is enormously important. So if you focus on the residential pie chart on the right-hand side of my slide here, you'll see that for a typical house that we build from scratch today, 2/3 of its carbon emissions happen due to construction. By the time you hand over the keys to the resident, 2/3 of its 50-year or 60-year carbon emissions life have already been emitted to get you to that point. And the remaining 1/3 occur in tiny quantities, really, operationally over the following 25, 30, 50 or 60 years, depending how you measure it. In other words, if we haven't dealt with embodied carbon, we simply haven't dealt with carbon properly. And that's not to say operational isn't important, we've just got really good at it. So we can do a great job of that and make it very, very low, or indeed zero, at which point the pie chart tells you that embodied carbon is the only deal we need to resolve. So we can't ignore embodied carbon, but we need to be aware that it's an emerging discipline from a fairly low starting point. I think that's a great moment to hand over to Neil and Dido for some more buildings-focused input.
Thank you, Joel. Next one, please. So, hello, I'm Neil Campbell. I'm a partner architect at VTW, and I'm here with my colleague Dido.
Hi, I'm Dido. I'm architect at VTW as well.
So we're going to talk through a kind of moving down the kind of scale in a way, our approach to buildings and the design of buildings with both architects, and the kind of complex and emerging legislation that we're working within. We have quite a number of local authority clients, and as such, I think often our brief exceeds that in other areas of kind of housing design, particularly because the standards are usually set higher, and that's great. So we're kind of exposed perhaps a bit earlier than the rest of the industry to some of the challenges that we're all facing in the design of housing. Next slide, please. So one of the things we were debating and trying to put together in preparation for this presentation is to find an easy comparison of the various regulations, both current and incoming, and where we sit today. And that was really quite a complicated task, we realised. So we've put together a very simple diagram here in an attempt really to explain the differences between the terms that we're hearing. I'm sure most of you will have heard all of the things that are listed here. And I mean, I suppose the main point is and the complexity that we face now is these various standards and regulations aren't comparing like for like, so we're not comparing apples with apples. But keeping it simple, starting with the current building regulations, and in the context of this presentation, we're talking about Part L, which is conservation of fuel and power, and Part F, ventilation, because those are the standards that we work to that are really measure currently within the context of what we're talking about in terms of conserving fuel and power, and how you can build more efficiently through ventilation. The second thing on here is the Future Home Standards, and this covers really incoming changes to the current building regulations in both those parts, L and F. And there's going to be a series of step changes, one in 2022, so next year, where there'll be a requirement for 31% less carbon reductions compared to current standards. So that's then comparing back to the building regulations we're working within now. And then as we move forward to 2025, a potential further uplift following the consultation process, which is underway now, which will move to a 75 to 80% reduction against current standards. Quite a step change there, and that's what we're working through now. And so there is an eye on things, where we're going with this. But there's a few really important things that this diagram highlights, is what that actually means in terms of net zero carbon, because that we're not comparing like for like, as I've said. One of the things the Future Home Standard relies upon is a requirement really that the homes are zero carbon ready as the national grid decarbonises. So that's quite a big deal, as Joel's already outlined there, and that's one of the things that's caused much debate in the Future Home Standards. So I'm just going to hand over to Dido to talk about the other 2 points here, and in particular the definition of net zero carbon.
So I think something that's important to point out about this diagram is we're trying to compare all the elements that the net zero carbon definition that the London Energy Transformation Initiative have set out, which is a holistic approach to carbon. So looking at the fabric, but also the embodied carbon, the renewables that you can have on site, and then a kind of monitoring system that is embodied in that, which gets you a full net zero carbon package, I guess. And the Future Home Standard and the current building regs, as you can see from the kind of colours, doesn't have an embodied carbon element to it. As Joel pointed out, it's quite a new and emerging area, so that's kind of be expected. And also the levels of monitoring in both the Future Homes and the current building regs is a lot lower than what you'd need to achieve net zero carbon in the LETI terms. So, for instance, the current building regs, there's been quite a lot of studies undertaken that are showing that the buildings that are being produced to those standards are actually exceeding the nominal figure that is set for the building to what its energy consumption should be. And there's been studies from about 2016 looking at how that process is, which I think is what's led to the Future Home Standard needing to be updated. And then obviously, because the Future Home Standard is in consultation, there's a lot of kind of push for it to come closer to what the net zero carbon definition that is a kind of industry standard, which is the LETI version, as it moves forward to 2025, because at the moment it doesn't seem to be kind of looking at that kind of holistic idea of carbon. Passive House is also on the slide because although it also doesn't have an embodied carbon element, it does have a kind of roadmap to achieving these figures that are in the net zero carbon LETI definition. So in that definition, there are a set of energy consumption targets and also heat demand for the fabric of the building, and they're incredibly similar to the Passive House figures. And that is a 30-year-old standard that's got proven data and existing buildings that hit those targets. So it's a really useful tool to hit the operational side of this standard. Next slide, please. So this is just a look at that LETI definition. So LETI is the London Energy Transformation Initiative. And I think the key things to see here are those figures. So the low energy use, which is the yellow section, is the kind of the operational standard that we're needing to hit. And as I said, that 35 kilowatts and the 15 kilowatts are incredibly similar to what Passive House gives you. Other things that are kind of really key that I've touched slightly are the kind of measurements and verification points through the process. So ensuring that you're measuring what you're producing, what your building's going to do during the construction phases and after the construction phases, so ongoing kind of measurements of what the building's doing. And then also the pink is the kind of embodied carbon and measuring reductions of that, and everything that's coming to site, everything that's going into the building can be measured and quantified. And then on the right hand side, we've got the dark blue, which is looking at the kind of the renewables that will be on site, and so balancing that energy that your building is using with the energy that you can produce on site. So by creating these incredibly efficient buildings that aren't using very much energy, you're able to produce the energy that you need on that site. And the final one is about balancing your carbon. So ongoing, looking at ensuring that there's a continued balance and kind of ecosystem of what you've done that is staying in balance as you go forward. Next slide, please. This slide is taken straight from the LETI Client Guide, which is an excellent document to help clients understand how you approach a net zero building. And it does things like explaining the kind of collaboration that needs to happen and the kind of thread that needs to follow through the whole process from stage 0 RIBA standards to stage 7. It also looks at kind of the myths and kind of thinking about the problems that clients have raised as issues with net zero buildings. So for instance, the cost increase. So there's a study by UK GBC looking at the price increase, and that's around 3.5% more expensive to produce buildings like this. But actually, if you balance that out against the benefits that you're going to get, so it's not just an economical benefit, you're going to get social benefits and economical in terms of the energy that you're using. That comes out less probably. And then, so this diagram looks at when the client needs to be involved and what their kind of the involvement with the team is throughout the process. Next slide, please. So as I said on the first slide, how do we go about achieving these figures and hitting the targets? And we like to think that the passive house system is a really good way to do that. So creating very thermally efficient, intelligent buildings using the kind of the site and thinking about designing well to achieve these things. But I think what sometimes gets forgotten when we're talking about net zero is that actually what does this produce in terms of the building that you're getting and for the people that are going to be living in these buildings. And actually what it's doing is creating very comfortable, very easy to live in buildings that are easy to run, have longevity, and are really comfortable to be in. And I think that's a really key thing to keep in mind when you're thinking about doing this as a process. Next slide, please. So this is looking at what the kind of elements of the design process would be. So the first thing to think about is the site and what have you got already on the site that you can use to your benefit when you're designing. So orientating the building and using the orientation of the building to gain free heat in the winter. Are there trees on the site that you can have free shading from? Are there existing materials or buildings on the site that you can reuse to keep your embodied energy levels down? And Neil's going to talk about this building on the right-hand side.
So there's an example here, Shakespeare House, that we undertook quite a number of years ago now, but I think it's more to make the point that it's not about new buildings all the time. In this case, this is reusing existing buildings. So this was an existing building within an estate, and we overclad this building, reorganized the internal arrangement, and actually put an additional floor on the top. And what that did was massively increase its thermal performance. We were able to carefully design the fenestration to regulate the solar gains, etc. Add additional areas for amenity, etc. So there are additional benefits just in terms of actually how the building is used. But overall, what that did was extend the building's life for another 30-40 years without knocking it down. And it sits very well in the context of the existing estate. Some of the buildings changed, some of them didn't. So I think what's quite interesting about this is, and the briefs that we get, is not always about having to knock something down and start again. And that certainly kind of plays to the point about the embodied carbon that would have been ingrained in that building and lost if it was knocked down and then a whole new building put in its place. Okay, next slide, please.
So the next element is thinking about the fabric. I like to think of this like a leaky bucket. If you've got a bucket with a hole in it and you're consistently pouring cold water into the top, it's going to leak out the bottom. So if you can think of the building fabric a bit in the same way, we need to keep that heat inside the building. And how do we lose heat? We lose heat through air transfer, so drafts and badly connected pieces of the building, and also through the fabric. So when one solid material touches another solid material, or there's a connection between the outside and the inside. So how do we avoid that? So thinking about a highly insulated envelope, keeping the envelope airtight, and also the elements that we put into the site, thinking about detailing very carefully so you're not getting thermal bridges, and also using high quality elements like triple glazed windows that, instead of being your kind of worst element in the building for losing heat, could actually be something for gaining heat. So in the winter, using that to increase, get your free gain, so you're not needing so much energy. Also, obviously, the other things to be aware of are keeping the elements out, so rain protection and wind protection and the normal things that you need to do with the outside of the building. And then and then that helps to ensure that the energy that you're putting into the building stays is relatively low and stays in when you've put it in. Next step, I'm sorry.
And I mean, just to touch on quickly, an example of exactly all of those points, where we undertook with Hounslow Council directly, this was very recently. So in this case, our brief was designed to Passive House principles, so not to full certification. But what that meant was that we used those principles through the design to maximise the performance of the building to a very high standard. So here there's triple glazed windows, simple repeated form, very highly efficient thermal fabric, and that is borne out in the architecture, and you can see that, and it creates very simple, beautiful architecture in our view. The next slide, please.
So then you've created yourself an envelope that holds your heat in and is fairly airtight and isn't leaking lots of heat out. So how do you ventilate that? And I think one of the things that people are most concerned about when you talk about passive house or you talk about net zero carbon buildings is the idea that you can't open your windows. And I'm going to talk about why that isn't true. So you have these MVHR systems, which is mechanical ventilated heat recovery, which is a way of ensuring that all the pollutants that you're creating inside the building are extracted, but you don't then bring in very cold air into the building that does exactly what you don't want it to do, and you don't lose any of your heat out of that system. So you're bringing cold air in, but it passes past the warm stale air that's going out and comes up to the same temperature as the building. So then you've got fresh warm air coming into the building using this system. But then in the summer, if you're wanting to open your windows, or if you're wanting to get cross ventilation into the house, that's totally possible, and you should do it. But I think the thing to remember is that because we've made the envelope so incredibly thermally efficient, it works both ways. So in the winter, it's stopping the heat escaping, but it's also stopping the heat coming in the summer. So you may not need to. I think is the thing to remember. Next slide, please. Okay, so the final piece of this puzzle is the fossil fuels element. And obviously we're trying to reduce the number of fossil fuels on the site, or remove them completely, and we're trying to balance the energy that the buildings are using and what's being produced on the site. So by creating this incredibly thermally efficient building, the amount of energy that you need to produce on the site is actually less than what you would need to produce previously. So there's space for solar panels for the electricity. There are ways of heating the building, such as air source heat pump that Joel's covered previously. And in kind of flat blocks and elements like that, you can use air source heat pump for the whole thing rather than individual for each element. And Neil's going to talk about this project on the left.
So another example of in Hounslow where we were looking at infield possibilities on estates, and this is an example of that. And it's up a scale really. I suppose we've shown examples of houses that are quite simple forms, but flat. The same principle exactly is applied to the design of flat blocks. So again, our brief was to utilise passive house principles when working through the design process of this proposal in Hounslow. And we arrived at a point through collaboration with a sustainability consultant, similar to the role that Joel undertakes, where we have a singular MVHR system in every single flat, but a combined heating source through air source heat pumps per block. So that there's a combination of those things that come together, and these things are quite complex, but then through the design and through the kind of process of design development with a wider consultant team, they, as long as they're designed in from the beginning, they're extremely effective. And one of the things we found that what it does is free up some space at ground floor, where previously you had a lot of ground floor plant. Now that's not necessarily the case. So a lot of this stuff is on the roof. Not least PVs, but also, the air source heating portions need to be on external facades or the roof, and it liberates some of the ground floor, which is great. So we're seeing some changes around kind of designs that we're able to achieve, and how we go through that process has become more technical, I think, but it's time well spent in the early stages.
Next slide, please. So in summary, I think it's really important to remember that this process isn't just providing net zero carbon buildings, it's also providing healthy and comfortable places for people to live, and which are have high performance and are efficient and intelligent. So it's improving the kind of the current building standard and quality of the buildings that we're producing. It's also there's also an efficiency in the form, so you're going to make economical savings potentially in the construction of the buildings, and they're much more economical to run. So there will be a reduction in fuel poverty, which I think is incredibly important at the moment, especially given the current news about gas prices and electricity prices rising, and also a longevity in the developments and the communities that are being created, because the fabric of the building is much more has much more longevity, because it's not going to be damaged by bad detailing or those sorts of things. And also kind of accountability and learning through monitoring what these buildings are doing. So the kind of ongoing monitoring of these buildings means that you have a better understanding of what your buildings are doing, how they're performing, than you would currently. That's it. Thank you.
That's great. Thanks very much. So thanks very much there to Joel Callow from Coda, Neil Campbell and Dido Graham, both from BPTW Architects. Fantastic, really good walkthrough. And I think we started very big picture, but we've got into some of the technicalities of the challenges of actually making net zero design happen. It's at this point I'm actually going to just pause a moment and say goodbye to our YouTube audience. So thanks for joining us on YouTube. I hope you've enjoyed this session, and just a reminder to look at Future of London's website, where we do have other events.